Okay, now if there would have been no friction, then tell me how much force was required in order to move B. If there would have been no friction, then in horizontal direction there would have been no opposition for the movement of B. So you could have applied any little amount of force and B would have moved. So now there is some friction, and suppose B there is moving. Now suddenly when you start thinking of friction, then what friction at this contact and this contact will do? Friction will try and oppose the relative motion. With respect to A, B is moving right. So A cannot move right. So what will happen is friction on B will act in backward direction in order to pull back B, so that it opposes the relative motion of B in forward direction. So from this contact between A and B, friction force is going to act in backward direction. Okay, and between the B and ground, again with relative to ground, B is moving in forward direction. So between B and ground, friction force is again going to act in backward direction because it's going to oppose the relative motion. So that's how the friction force will be acting, and this is how the external force is acting. So B will start to move just when the external force equalizes the friction force, sum of both the friction forces. That's what you have to do. And the friction force on A will be acting in forward direction because the friction force will try and minimize the relative motion. It is going to oppose the relative motion, so it's going to yank down B and it's going to give a boost to A in forward direction. So although there's rod, so the A cannot move ahead, but nevertheless friction force will be acting on A in forward direction because it's an action-reaction pair. On A, the friction force will be acting forward. Friction force, like normal reaction, remember, is the action-reaction pair because it's the very cause of it is the rubbing of two surfaces. So it's going to act on both the surface, both the contact surface. So on A, the friction force is going to be in forward direction. On ground, the friction force is going to be again in forward direction. It's an action-reaction pair. Okay, so we are concerned with B. Now let's find F1. How much will be F1? Friction force is mu into N. That's the formula we have learned in this chapter. So F1 will be mu into N1. Mu is given as 0.2 and N1 is the normal reaction. Normal reaction will be balancing the mass, the weight of A. So N will be equal to mg. Mg would be equal to 1000. So the friction first F1 is coming out as 200 Newton. Similarly, you can see that the mu is 0.3 and the normal reaction at this point, remember, normal reaction at this point is going to be because of the weight of both A and B. So the normal reaction here is going to be the sum of these masses times G. So it's going to be 3000. So F2 is 0.3 into 3000. That comes out 900 Newton. So the total force that you have to apply to just balance the opposing force will be 1100 Newton. Okay, so if we just apply this amount of force, it will have a tendency to move. If you increase the force by a little more than this, then the block B will start moving. Okay. Okay, now the third problem you should be able to solve on your own. A, B, 10 kg, 5 kg. Mu, suppose at this contact is 0.3 and at this contact it is 0.4. Right? If I just leave the system like this, then A and B are going to fall. This is the ground. Right? A and B are going to fall because the friction force at this contact will not be acting. Can you tell me, just at this moment, I have not done anything, I've just put A and B in the position shown and I have left the system. Then what would happen? A and B are going to fall. And before that, tell me how much of the friction force will be acting at this contact. Now at friction force we know is mu into N. And at this contact there is no normal reaction. If we draw the FBD of B, there's only mg acting downward. There is no horizontal force because these two are not pressing each other. They both will be falling down under the force of gravity, and this contact is not being pressed. So there is no friction force at this contact, first of all. So they are going to fall. You have to appreciate that. Now, in order to keep the whole system as it is at stationary condition, then suppose a force F is applied here. So that a friction force appears here, a friction force appears here, and that force F balances mg. And the whole system remains stationary. Now all you have to do is, you have to tell me what is the minimum amount of force that you should apply here in order to keep the entire system in static position. Okay, so it's time for you to get started with friction. So, get your answer. The answer would be, and listen to the answer only if you have got one. The answer would be the minimum amount of force required is 250 Newton.